In this video, I'm going to solve this question I have on the screen, which says that you should consider the voltage regulator used to power the cell phone at a 2.5 volts from the lithium ion battery, which voltage may vary between 3 and 3.6 volts. The current in the phone will vary from 0 to 100 milliampere. We should calculate the value of Ri and then the Zener diode power dissipation, considering Iz to be, that's Iz minimum to be 0.1 times what Iz maximum. Okay, so that's the question you have on the board here. But before we continue to solve the question, let's look at some few things here. So in this circuit here, we have the power supply, have the resistor Ri, you have the Zener diode, and then the load here. Okay, so this is the load resistor here. And then in this, you see that you have the current from the source, and then you have the current in the Zener diode, and then you have the current in the load. So looking at this, you see that the Zener diode is connected in the reverse bias mode. That's the negative side is connected to the positive, and then the positive side is connected to the negative. That's how Zener diodes are used. It is used in the reverse bias state. Okay, so now let's look at some few things here. Let's write an expression for the sum of the current in this circuit here. So looking at this, you see that from Kirchhoff's law, it says that what current moving towards the node equals what the sum of the current moving away from the node. So you see that the input current is moving towards the node, and then the Zener diode current is moving away, and then IL, which is the load current, is also moving away. So in that case, you can see that what I input, let me make this, we can see I input will be equal to what Iz plus IL. This is what you have here. Okay, so what about the resistor here? Okay, what about this resistor here? If you want to find the value of this resistance, what will be the formula for this resistance? So from Ohm's law, you know that what voltage was what current times what resistance, right? So if you want to find the resistance, you can make R the subject. So resistance will be equal to what voltage over what the current. Okay, so in this case, you want to find Ri. So you see Ri will be equal to, let's make VR the voltage in the resistor. So that's VR over what I. Okay, which is the current in this resistor here. So this is what our formula now becomes. Okay, so now before you can find this resistance here, you must know the voltage, and then you must know what the current here. But already you know that the current the input current here equals what Iz plus what IL. But what of the voltage here? How do you find the voltage across this resistor here? Okay, so you can do this easily by subtracting the voltage at this node from the voltage at this node. So the voltage at this node is the voltage from the power supply, and then the voltage at this node is the voltage in the Zener diode, which is what Vz here. Okay, so this side is the voltage from the power supply, which is Vps, and then this is the voltage in the Zener diode, which is what Vz. So Vr will be equal to Vps minus what Vz. So that will be Vps minus what Vz over I, and you know I is what equal to Iz plus IL. So this is what our formula now becomes. Okay, so for us to be able to use this formula, we must follow some conditions here. Okay, you must follow some conditions here. So let's go ahead and then look at the conditions. Okay, so the first condition here is that when the input voltage is maximum, okay, when Vps is maximum, then the current in the Zener diode will also be at its peak. That's, it will also be at the maximum current level, and then the current in the load will be what minimum. So that's to say that when Vps, that's when the voltage from the power supply is maximum. Okay, when the voltage from the power supply is maximum, then the current in the Zener diode will also be at maximum, and therefore this will cause the current in the load to be at minimum. Okay, so the reason I'm saying this is that the reason for this condition is that you know that what I input equals what Iz plus what IL. Okay, so what happens is that I input here, okay, is a constant value. Okay, I input here is a constant value, so you know that what when you sum up these two, it will give what I input here. Okay, so what happens here is that since the sum of these two will give this, when when one of them is reduced, one must be increased for us to get the same value. And then when one of them is decreased, one must be what increased so that we'll be able to get the same value here. So let's look at this. So we want to get the same I value here that I have here. Okay, so we know that the sum of these two should give this I value here. So when I increase the current in the Zener diode, which will give me IZ mass, okay, then IL will reduce. That will be plus what? IL minimum, because you want to get this same value here. Okay, because the sum of these two should still give us this. Okay, so when this one increases, this one must reduce so that at the end when we add them, you still get this. And also when I reduce the IZ, when IZ is reduced, then we can increase the IL, okay, so that you will still get the same value that we have here. Okay, so that we still get I to be this. Okay, so when we increase the IZ mass, the IL minimum the IL has to reduce, and then when the current in the Zener diode is reduced, then the current in the load has to be what? Increased. So this, so we consider this. Okay, we consider the one at the top when the input voltage is maximum. Okay, and then we consider this when the input voltage is what? Minimum. So these are the two conditions here. Okay, so now let's look at this. So okay, let's continue from here. We come back to the question. So from here, what I'll do is that, let's say now you have the voltage from the power source to be at maximum. Okay, when the voltage from the power source is maximum, so let me take here. So we use this when the VPS is maximum, and then we use this when VPS is what? Minimum. Okay, so the voltage in the Zener diode doesn't change. Okay, it is always constant, so that it will supply a constant voltage to the load to prevent the load from getting damaged. Okay, so this is what happens here. So you know that when the voltage from the power supply is maximum, our I becomes this, and then when the voltage from the power supply is minimum, this becomes the value of what? Our our I. So now let's rewrite this formula here. So our I here, let's say in this case you want to find the value of what? Ri, but the voltage from the power supply is maximum, so that will be Ri will be equal to VPS max. Okay, that's the voltage from the power supply is maximum. Okay, so that will be VPS max minus VZ. Okay, all divided by what to be the value of I this time around. That will be what? IZ max plus what? IL minimum, because the power supply is what? Is maximum. So that will be IZ max plus IL minimum. Okay, so when you use this formula, we'll be able to get the value of what? This Ri here. Okay, so same way we can find Ri, okay, when the voltage from the power supply is also reduced. So when the voltage from the power supply is at its minimum, they are going to use this formula. So that's VPS is minimum, then that will be VPS minimum minus what? VZ, and then all this divided by what? This value of current here. So that will be what? IZ minimum plus IL max. Okay, so all this will help us to find the value of what? R here. So if you want to find Ri, you can use this formula. If you want to find Ri, you can also use this formula here. So this, what you have at the top here, will give the same answer as what you have at the down here. So let's look at that. I'm going to write this one and then equate it to this. Okay, since they are all supposed the same answers. So let's look at that. So these two becomes, I have VPS mass minus what? VZ. Okay, all divided by IZ mass plus IL minimum. Okay, this should be equal to VPS minimum minus what? VZ minus VZ. Okay, all divided by IZ minimum plus IL maximum. Okay, so I created this because when we take this, what you have here, okay, this will give me Ri, and then when we take this also give me what Ri, and they are the same value, so therefore we can equate the two here. Okay, so this is the formula that you are going to use in answering our question. Okay, so I'll go ahead and clean the board, then we now go ahead and solve our question here. So now that you have this formula, you are going to use this formula to answer this question I have on the screen here. So now for this to be able to, for this to be easy for us, let's list down the data that we have here. Okay, so first of all, we have the voltage regulator used to power the cell phone is at 2.5 volts. So this will give us the voltage in the phone, okay, which is the voltage in the cell phone, which is the same as the voltage in the load. So in this case, the Zener diode is the one supplying this voltage to the load, okay, and you can see here that the Zener diode is in parallel with the load here, so that means that the voltage across the Zener diode will be the same as what the voltage across the load. Okay, so you can see that what Vz will be equal to what VL. In this case, the voltage in the load is given to be what 2.5, so this should be equal to what 2.5 volts. Okay, so the next data we are given is the voltage input. He said so he derived the 2.5 volts from the lithium ion battery, which voltage may vary between 3 and then 3.6. So the lithium battery here is the voltage source, okay, which is this VPS here, but it is varying between 3 and then 3.6. So I will say that VPS minimum should be equal to 3 volts, and then VPS maximum should be equal to what 3.6 volts. Okay, and then the next thing we have to look at is said the current in the phone will vary from what 0 up to 0 milliampere. So the current in the phone, so that's the load current. Okay, so the load current, the minimum one is 0, and then the maximum is what 100. So you have IL minimum to be equal to 0 milliampere, and then IL maximum will be equal to what 100 milliampere. Okay, and also we've been given that what Iz minimum equals what 0.1 Iz maximum. Okay, so these are the data that we need here. So you know that Iz minimum equals 0.1 Iz max. Okay, so this is what you have here. So I'm going to use this data to solve this question that we have here. So first of all, we've been asked to find the value of what Ri. Okay, we've been asked to find the value of what Ri. Okay, we know that Ri will be equal to what Vps minus what Vz over Iz plus what Il. So we can use this formula to find what Ri here. Okay, so now why don't we just put in our values and then solve for Ri? So let's look at this. So we know Vps here, we know Vz, Iz, Il, but Iz is not given in the question here. Okay, so Iz is not given in the question. So before we be able to solve for Ri, we must know Iz here. So how are you going to find Iz? Okay, so you are going to find Iz using this formula here. Okay, so you see you have Iz max here, and then you have Iz minimum here also. So you are going to use this formula to find one of them. Okay, so let's go ahead. So first of all, let's substitute in our values. Okay, so let's go ahead and do that. So you know that what VPS max is 3.6, so I'm going to do that here. So that'll be 3.6 minus, I think that's too small. So VPS max is what 3.6 minus what VZ, and VZ is 2.5, so minus what 2.5. Okay, divided by Iz mass. Iz mass is not given, we don't know Iz mass, so let's write Iz mass here. Okay, minus plus what IL minimum. So IL minimum is given to be 0, so that's plus what 0. So this should be equal to VPS minimum. VPS minimum is 3 volts here minus Vz, which is what 2.5 in this case here. So divided by Iz minimum. Okay, so you know Iz minimum, we don't know Iz minimum also, so let's write down 2 down. Iz minimum plus IL max, which is what, 100 milliampere. Okay, so this is what you have now. Okay, so now we have Iz max here, we have Iz min here. So which one do you want to find first? You can find any of them first here. So let's see, we've been given that Iz minimum equals to 0.1 Iz max. So we can do some substitution here. So wherever we see Iz minimum, we can substitute this there. So that will be 3.6 minus 25. Okay, let's simplify this. So 3.6 minus 2.5, that will give me 1.1. So that will be 1.1 divided by Iz mass, okay, plus 0. So it's the same thing, to give me Iz mass. Okay, equals 3 minus 2.1, sorry, 3 minus 2.5. So that gives me 0.5 here. Okay, all divided by Iz minimum plus what, 100. But I know Iz minimum equals what, 0.1 times what, Iz maximum. So that will be 0.1 Iz max, okay, plus 100. Okay, so this is what I have here. Okay, so now that you have this, you see that you can solve for what, Iz mass, right? You can solve for Iz mass very easily. So let's do some cross multiplication here. So that will be 1.1 here, okay, into bracket, 0.1 Iz max, okay, plus 100. This should be equal to 0.5 times Iz max. Okay, so this is what I have here. So now let's continue. So 1.1 times 0.1, so that will be 1.1 times 0.1. Okay, so I'm going to multiply what you have in these brackets by what you have here. So okay, let's not make this confusing. So first of all, let's open this bracket here. Okay, so I'm going to open this bracket here. So that will be 1.1 multiplying with 0.1 Iz mass, okay, plus 100, plus 100. This should be equal to 0.5 Iz max. Okay, so now let's multiply. So that's 1.1 times 0.1. So this will give me 0.11 Iz mass, okay, plus 1.1 times 100 times 100. So this gave me 110. So this will be equal to 0.5 Iz max. Okay, so now let's continue. Okay, so from here we want to find Iz max. So let's take this value to the right hand side. Okay, so this will give me 110 to be equal to 0.5 Iz mass minus what, 0.11 Iz mass, Iz mass. Okay, so this is what you have now. Okay, so now let's simplify this. So this will give me 110 to be equal to 0.5 minus 0.11. So that give me 0.39 Iz mass. Okay, so from here you can divide by 0.39. You can divide by 0.39 here. Okay, so let's see what you get for Iz. So that will be 110 divided by 0.39. Okay, so that gives me Iz mass to be equal to 282.05 milliampere. Okay, so that's the value. Okay, so now that you've gotten the value of Iz mass to be 282.05 milliampere, you can go ahead and then solve for the value of what, Ri here. Okay, and previously during the introduction, we learned that what we can use two formulas to find for Ri here. So we can use this formula Ri to be equal to Vps max minus what, Vz over Iz max plus IL minimum. Okay, we can use this formula, or we can use this one also, Ri to be equal to Vps minimum minus what? Vz all over Iz all over Iz minimum plus IL maximum. So you can use this any of these two formulas to solve for it. Ri. Okay, so in this case here we found uh Iz mass to be 282.05 milliampere. So in this case we can use this first formula here. So that will be equal to Vps mass. So we got Vps mass to be 3.6. So that will be 3.6 minus Vz, which is 2.5. Okay, all divided by Iz mass. Then Iz mass is now 282.05 milliampere. So plus IL minimum, but IL minimum is given to be what? 0. So this will be 282.05 milliampere. So that will be times 10 to the power what? Minus 3. So let's see what we get for this. So that will be 3 3.6 minus 2.5. So that gives me 1.1. So that will be equal to 1.1 divided by 282.05 times 10 to the power minus 3. That's divided by 0.28205. So let's see what we get at the end. So 1.1 divided by this. So that actually give me 3.9 ohms. So that will be the value for Ri here. Okay, so if you don't want to use this formula, you can use this second one here also. So let's look at that one also. Okay, so to use the second formula, you know that what we are using Vps minimum minus Vz, and then Iz minimum plus what? IL mass. But in this case, we don't know IL minimum. Okay, but we know Iz mass. So I'm going to find IL minimum. So let's come back to this formula here. We said what? Iz minimum equals what? 0.1 times what? Iz mass. So you can find IL, sorry, you can find Iz minimum here. Okay, from this formula where Iz minimum equals 0.1 times what? Iz mass. So that will be equal to 0.1 times 282.05 milliampere. Okay, so what will be the value for this? 0.1 times 282.05. So this gave me 28.205 here. So let me clean all this and then write down. Okay, so that gave me 28.205 milliampere. So now that you know the Iz minimum, you can go ahead and then solve for the Ri using this second formula here. So Ri will now be equal to Vps minimum. So that's 3 minus Vz 2.5. Okay, divided by Iz minimum, which is 28.205 milliampere. That's times 10 to the power minus 3. Okay, plus IL mass, which is what? Which is 1000 milliampere. So that'll be, which is 100 milliampere, sorry. So that's plus 100 milliampere. So that's 100 times 10 to the power minus 3. Because when I do this, this will also give me Ri to be what? 3.9 ohms. So you see that what? When you use this formula also, you got the same answer. So you can use any of them to solve for your Ri. So you know the Iz mass and then the Iz minimum. Let's find the power dissipation in the Zener diode. Okay, so in this case you have the maximum power dissipation and then the minimum power dissipation. So let's find both of them. So you are going to use the formula power equals current times voltage. So this is the formula I'm going to use here. So for the maximum power dissipation, you are going to use the maximum power here. So Pz mass. Okay, that will be Iz mass. So Iz mass is 282.05 times Vz. Okay, Vz is what? 2.5. So that will be times what? 2.5. So let's see the answer for that. So 282.05 times 2.5. So that gave me 705.125 milliwatts. Okay. Alright, so now that you know the PZ max, let's find the PZ minimum. So PZ minimum will be equal to IZ minimum. So that will be 28.205 times VZ, that's 2.5. So let's see what you get for that one also. 28.205 times 2.5. So that gave me 70.5125 milliwatts.